All right, folks, let's jam through the rest of this video. So we didn't get to the thing called the feasible region today in class, but that's the feasible region is really what it's all about. Remember, Alex was constrained in three ways. Through the amount of fabric he has, right? He has those 6 yards, or is it 7 yards of fabric? He's also constrained by 198 inches of elastic, and he's also constrained by the fact he's got to get more than twice as many adults mass as child's mass. There's a lot kind of going on in this problem they built for you guys here. Anyways, today, right, hopefully you know how to graph an inequality now. That's good. But you need to graph more than one because he has more than one constraint, okay? So we want to find a feasible region at the end of this that's going to be the solutions to multiple, those three inequalities together. We need to find the common set of solutions, okay? So you guys did great here. I was eyeballing this a second ago. It looks like this person, Gregory Margulis, probably had them reversed here. That was a common mistake that we had. So graphing the elastic inequality, you guys did that. I kind of reviewed that a lot here. Change into an equal sign. Okay, and then get your y-intercept, right? The y-intercept is going to be where we see C here. So y-intercept is going to be the value of y when x equals 0. Okay, so 0 plus 12x is equal to 198, right? You guys should know what to do it to solve. 12 times x equals 198, so that means divide both sides by 198. That's how we get to 16.5, and boom, looks like 16.5, 16.5, 16.5, all those y-intercepts there. Same thing for the x-intercept, right? We plug in 0 for y, and then we're left with 14x equaling 198. Divide both sides by 14. Boom, get the intercept. Okay, so that's how we can quickly graph those. And we'll practice that again in the future. Don't worry about that. Okay, through 2 points, exactly one line can be drawn. I don't know how that person's graph didn't end up there. I guess they didn't type the equation in, but you're supposed to type the equation in to verify that. For instance, if I have this, if we got this here, it's like this person's got it all. So if we have an intercept of 16.5 for y and intercept of 14.1 for x, we can just draw in that borderline. And then if you type this in, it verified, hey, that's the correct borderline. You're good to go. Okay, so next slide that you had to do, and please pause this, answer the questions, unpause this, keep doing it with me here, is what would be great to test a point to see if it's true or not. Now, they didn't show their work. They didn't explain their answer, so maybe we'll look at somebody else's here. So here I got my borderline. So my true solutions, my inequality graph can either go up here or it can go down there. And Desmos isn't going to show it to you yet. So I'm going to go ahead and scroll down because a lot of people were testing 0, 0 on this one. Let's go to this here. It's slide 8 that we're on. Okay, a lot of people testing zeros. Some people tested other points. Can you test other points? Sure, that's fine. You can do that. But it might be easier to do 0, 0 because then it's just simple. 0 is less than a positive number. Cool. And we know that is true. A lot of people showing work here, which is great. So Girolamo Cardano, these are all fake names. Oh, wait, you told me the real name. Sorry. 14x plus 12y is less than or equal to 198. So you have your borderline already. Now you want to test in the inequality, right? Because the points below the borderline, they're either going to be all true or all false. And if we plug in 0, 0, remember 0, 0 is the origin, we're going to know whether the origin is true or false. We're going to know whether we want to shade towards the origin or we have to shade away from the origin because the origin's false. And as Girolamo here has shown us, the origin is true, right? We plug in 0 for x and 0 for y. There we go, right? 14 times 0, that makes a 0. 12 times 0, that makes a 0. And then 0 plus 0 is 0, and 0 is definitely less than or equal to 198. So that's a true point, and you guys were putting in true here, just saying it's true. Just to remind yourselves, if I'm doing this by hand, I'm shading that side. Okay, shading that side. Okay, so that reminds you of how you graph this. This one here, this point was this question was kind of silly. This was just like, well, let's just see what our graph looks like. Let's see if we're right. Yes, 0, 0 is part of the solution region. Yes, my y-intercept's at 0, 16.5. My x-intercept is about 14.1 or so, right? 14 and 1/7, as Dylan said today in class. And so I graphed it all right. Now here it is. I have my graph. Okay, so then I'll go to this, which is, and they don't show you this here. Here's a graph with all your points. So maybe I'll have to look at a student's to see what you guys see here. I'll stick with Girolamo Cardano. And then this thing doesn't really show you anything. It just shows you the true point. Okay, so you're saying this point is a part of the inequality, but there are a lot more. Okay, there are a lot more. This is what Desmos shows us. Yep, 0, 0 is in the solution region, shows the border question here. What is similar between your graph you started? Okay, we didn't finish shading. We didn't show all the points, right? We want to show all the points because all the rest of the points are true, okay? I think it's the same. 0, 0's points true is shaded. It's just that mine isn't shaded. Well, your 0, 0's on there. To get a full inequality graph, you need to shade all other points on that side of the borderline. This half plane of the coordinate plane is all true solutions, right? All true solutions here, okay? Going to the next slide. Let's see if Girolamo's still working. Looks like Girolamo hasn't started working yet. We get to the good stuff. I will save this for a second video because we got a second video happening for feasible regions. So, talk to you guys in a second.